Hello and welcome to IP Fabric webinar about change verification using snapshots and intent-based networking. Today we are going to talk about change management from engineering point of view and what is needed to prepare the change, verify the change, and how we can mitigate the risks that is associated with changes. And how can intent-based networking help you in continuous digital transformation across your network? So first of all, I wanted to talk about the requirements. What do we need in change management? Essentially, we want to plan, prepare, and execute the change perfectly and report the results of that change. We need to answer a number of questions before we, in the planning phase, such as what is actually being changed. Uh, we need to thoroughly understand the technology that is being changed, how the change should proceed, and gather all the facts before the preparation stage. We also need to assess what is actually being impacted. Will there be any outages during the change? What is the intended result of a change? Do we expect a service to be improved? Um, and we need to understand what are the associated risks. The network by itself can work without a hiccup until a change occurs. And then when a change occurs, it can be far-reaching and result in unintended consequences. We want to control all of the aspects of network infrastructure, such as when we change one part of the network, that it doesn't adversely impact another part of the network. For example, if we are changing a routing policy on just one single site of a global network, that routing policy at one remote location can actually propagate an incorrect route and cause a black hole for a wide range of networks that could adversely impact the whole network worldwide. Uh, it's a nightmare of every engineer that a simple change actually causes a global network outages. Uh, and this isn't a an isolated case because such issues occur rather frequently. So what is the risk with change management? It's that we either miss something that we should have known beforehand because of immense network complexity. There is a wealth of network state data that needs to be analyzed and gathered. And in this phase, it's very easy to actually miss something. Not only from the point of view that you miss some systems that would be impacted by the change and would go offline during the change, but also from the point of view that a technology really does not operate as you expected it to operate before the change. So the big question is then, how can we reduce this risk? How can we ensure that there will be no adverse impact? And our answer to this is in-depth snapshots and intent-based analytics, where we ensure that all of the network state data is gathered before and after the change, and that we provide access to all of the data at all times, meaning that even if you realize that you need certain data to analyze the change further after the fact, you can go back in time and find that specific data point in a historical snapshot that will provide you this information. And most importantly, we want to provide you an ability to verify that the change is performed as expected, and ensure that the change was for the better and did not adversely impact the network. So let's look at this practically from the user interface of IP Fabric platform, and let me share that with you. When we want to prepare a change, we simply take a new snapshot of the network and ensure that we have gathered all of the current state data. And also rely on existing snapshots that was taken on a basis. So let's say we have taken a snapshot. We can rename the snapshot that it's network before a certain change, and prepare that specific change thoroughly. In this case, we are interested in one particular site which has a problem. So the problem that we are interested in solving is a missing redundancy in the current network. So to see what is exactly where the redundancy is missing, we can visualize the part of the network that needs changing, and see that exactly where the change needs to happen. In this case, in this design, there is a redundancy missing for that particular site, where we see that outbound connectivity from the site is established through a BGP routing protocols, and which is connecting to gateway routers of the site. However, one of the gateway routers is not connected to other routers at the site, except the other gateway routers. So in this case, we want to provide redundancy for this site, and we want to enable this site to function even in case of a single device failure. In this case, the single point of failure here is in EXR2 or R4 devices that are displayed on the diagram here. We can display much more information about any of the devices by simply clicking on the device and seeing the specific information about present interfaces, routes, routing protocols, and so on. In this particular case, we simply want to enable routing towards the external router. To verify the impact of the change, we can take this site and find all of the users that are reliant on this site connectivity. So if we'll go to host inventory, we can find out the specific site and see all of the hosts that are present at the site. So this list immediately gives us a complete overview of all of the individual hosts that are served by this site, and provides us a list of devices that might be impacted during the change. So when project manager asks you what kind of systems will be impacted and what is the role of this system. You can provide them the whole list of all of the impacted devices and provide detailed information about host connectivity in case that is needed. This step already ensures that you are not surprised when a certain system would go down in case the change doesn't go as expected, and have all of the information in your initial impact assessment. You can also export this information and share it with the team in legacy Excel format, or you can simply copy a link that will then be used to share within your team. So that's in this way you can ensure that the impact of the change is fully known. Additionally, if the system is connected to the DNS, we could know what specific host names of those systems that are being used, and see if these systems actually provide some services towards other parts of the network. Beforehand, we can also ensure that the routes that in this particular sites in this particular site are also present throughout the network. So here we can see what specific routes are connected in this particular site, and we want to ensure that the presence of all of these routes throughout the network before and after the change. So this is a pre-change snapshot. So we know all of the routes that are connected in that site. Again, we can store this information for sharing, or simply copy the view for sharing within the team. You can look also at the specific protocols protocol that we are interested in changing. In this case, at this particular site, we can see the all of the routing protocol sessions that are established in this particular site, and we can also gather this information for analytical purposes. So in this case, we can see all of the OSPF sessions that are present, and what we want to ensure is that these sessions are not affected, inadvertently affected by the change. After performing the change, we can ensure that the change has gone as expected simply by taking another snapshot of the network and after the change, and visually verifying that first the change has happened as expected. So in this case, and let's save this view as our change window. Where before the change, we saw that there were single points of failure and non-redundant links, while after the change, we have established another routing session. Now there are no more single points of failure or non-redundant links in this particular topology. To ensure that the hosts still have connectivity, we would need to ensure that hosts are still reachable within the network. We can either verify that in the host tables by comparing the previously prepared list with a list available in the new snapshot, or we can create a rule that would do this automatically for us right in this table. We can then verify that the routing has changed as expected by looking at the new routing sessions that were established at that time for that particular site. Unfortunately, in this case, we can actually see that some of the routing sessions, that a number of routing sessions were affected that we did not intend because their session time is much lower than expected. And we can actually see if this situation was a problem before as well, because this routing problem did not result because of the change, but it's actually was something that was always present and that was always affecting the network. So this is an example of where we needed an access to this additional information only after the fact, after the change. But we can go back in time and see what was the status of that change, of what is the status of the network before this particular change. We can also verify the changes themselves by comparing the pre-change snapshot and post-change snapshot and see exactly what has changed from the device's point of view, part numbers, IP addresses, or connectivity matrix. In this case, we are interested in added and removed IP addresses at our particular site. And we can see that actually there wasn't just a single change happening, but a number of IP addresses have been added or removed within that site. We can also verify the actual routing sessions that were established, and in this case we can see that a new routing session has been added, which provided an additional connectivity on the external router. However, there were also a number of other sessions that have been added or removed inside that site. So overall, we can see that although the change was completed as intended, there are a number of unintended consequences, and we can go back and in time and see if those unintended consequences were a part of the site, a part of the change procedure, or if they actually were always present in the network and just surfaced with the change. So I hope this presentation was useful and you could see how IP Fabric can help you with the change management in your network. Thank you for your attention.